Measures of dispersion, part 5.
Hello everyone. In this session we will discuss a few more concepts. This is continuation of a previous video. Variance and standard deviation for discrete frequency distribution. So here we know that a discrete frequency distribution means, here let x1 comma x2 comma and so on xn, which are n observations, and f1 comma f2 and so on fn, which are their frequencies. Now clearly the given problem containing observations and frequencies, then we can say that frequency distribution is called discrete frequency distribution. See here, in that we know that x bar is what? Mean formula is sigma fi xi, which is divided by n. N is what? N is sum of the frequencies, that is sigma fi. And also variance formula, we know that variance which is equals to 1 by n into sigma fi into modulus or xi minus x bar whole square. So this is the variance formula. Now we know that standard deviation, which is what? Square root of the variance. And variance is denoted by what? Sigma square. So based on this we have few 7 marks questions, so that are very important. So video skip cheyakunda end work chudandi. See the question number 1. Find the variance and SD. SD means standard deviation of the following data. So clearly this data contains observations and frequencies. So therefore which is called as a discrete frequency distribution. Okay. And we know that in the discrete frequency distribution, the mean x bar, which is defined as sigma fi xi divided by what? N. And also what is the variance formula? Variance is equals to 1 by n into sigma fi xi minus x bar whole square. So we have to find mean, after that variance, next standard deviation, that is what? Square root of the variance. So first we have to construct the table. First we can write the observations and frequencies, xi values, next fi values. For finding the mean, we can find fi and xi values. So multiplying fi and xi. After that you can find the mean. Next we can write xi minus x bar values. Xi minus x bar. After that xi minus x bar whole square values. Next multiplying with the frequency, that is fi into xi minus x bar whole square. So we have to write the values of xi, fi xi, xi minus x bar whole square, fi into xi minus x bar whole square. So first you can find fi into xi. So multiplying these two, 4 into 3, 12, 8 into 5, 40, 11 into 9, 99, 17 into 5, 85, 20 into 4, 80, 24 into 3, 72, 32 into 1, 32. Now we should add all these. That is what? Sigma fi xi values. So what will you get? 420. Next we can add all the frequencies. Clearly you can find mean, that is x bar is equals to sigma fi xi divided by n. So here what you got? Sigma fi xi 420. So which is divided by capital N. Capital N is 30. 0 0 cancel. So 42 by 3. Clearly which is equals to 14. Therefore mean x bar is equals to 14. So therefore the mean value x bar is equals to what? 14. So you can find xi minus x bar, that is 4. 4 minus 14 minus 10. Next 8 minus 14 minus 6. 11 minus 14 minus 3. 17 minus 14 3. 20 minus 14 6. 24 minus 14 10. 32 minus 14 18. Next you can find xi minus x bar whole square. Minus 10 square 100, minus 6 square 36, minus 3 square 9, 3 square 9, 6 square 36, 10 square 100, next 18 square 324, and multiplying with the frequency. 3 into 100 300, next 5 into 36 180, 9 into 9 81, 5 into 9 45, 4 into 36 144, 3 into 100 300, 1 into 324 324. Now we should add all these. You will get 1374. So which is what? Sigma fi into xi minus x bar whole square values. Now using this values we can find the variance and standard deviation. First, variance. We know that variance formula is 1 by capital N into sigma fi into xi minus x bar whole square, and which is equals to 1 by n. What is capital N value? 30, and sigma fi into xi minus x bar whole square, which is 1374. Now we can calculate this. You will get 45.8. So this is the variance. Therefore standard deviation, square root of the variance, that is square root of 45.8. So which is approximately 6.77. So this is the variance and standard deviation. So next, variance and standard deviation for continuous frequency distribution. And we know that continuous frequency distribution means the given problem containing close intervals like 0 to 10, 10 to 20, 20 to 30. So that is called what? Continuous frequency distribution. So here we know that for continuous frequency distribution, the mean formula, that is x bar equal to, so already we discussed in the previous class, that is a plus sigma fi di, which is divided by n into h. Here a is called assumed mean and fi is what? Frequencies, and di equals to what? Xi minus a divided by h. And what is h? H is the length of close interval. Now we can find the variance. So here we know that variance formula, which is equals to h square by n square into capital N into sigma fi di square minus sigma fi di whole square. So this is the variance formula. And what is the standard deviation? We know the standard deviation is square root of the variance. So based on this, we have few questions that are very important for annual examinations. So next, see the question: calculate the variance and standard deviation of the following data. So clearly this data containing close intervals, therefore which is called what? Continuous frequency distribution. And for continuous frequency distribution, the mean formula x bar equals to a plus sigma fi di, which is divided by capital N into h. And what is the variance formula? We know that variance is equals to h square by n square into capital N sigma fi di square minus sigma fi di whole square. Okay. For finding the values of these, first we can construct the table. First write what? Class interval. Next we can write frequencies, that is Fi. After that you can write the xi values. What is xi? Midpoint of the class interval. After finding the xi, next we can find di values. So what is di? Di is equals to xi minus a divided by h. After finding the di values, squaring them, that is di square. After that we can find fi di square. After that we can find fi di. So we have to write the values of all these. So using the table you can find mean and variance. So first we can find xi. Xi is what? Midpoint of the class interval. What is the midpoint of the class interval? 35. Next, midpoint of 40 and 50. 45. Next, 55, 65, 75, 85, 95. Next, we can find dA. dA is what? xi minus a by h. See here, we know that a is what? Assumed mean. So, you can consider any midpoint of the class interval. For example, you can consider 65 is the assumed mean. So, a is equal to 65. And we know that h is what? Length of the class interval. What is the length of 30 and 40? 10. So, h is equals to 10. Now, we can find di values. That is xi minus a by h. 35 minus 65 minus 30 divided by 10. That is minus 3. Next, 45 minus 65 divided by minus 10. That is minus 2. Next, minus 1, 0, 1, 2, 3. You can write directly. Next, di square, square of this, minus 3 square, 9, minus 2 square, 4, minus 1 square, 1, 0 square, 0. Next, 1 square, 1, 2 square, 4, 3 square, 9. Next, multiplying fi and di. Frequency, this is what? fi, 3 into minus 3, minus 9, 7 into minus 2, minus 14, 12 into minus 1, minus 12, 15 into 0, 0, 8 into 1, 8, 3 into 2, 6, next 2 into 3, 6. Next, fi di square, so 3 into 9, 27, 7 into 4, 28, 12 into 1, 12, 15 into 0, 0, 8 into 1, 8, 3 into 4, 12, next 2 into 9, 18. Now we should add all this. So we will get 105. This is what? Sigma fi di square. And again add all this. We will get minus 15. That is sigma fi di. Now we can calculate the variance and standard deviation. So first, variance. We know that variance formula is equals to h square by n square into n into sigma fi di square minus sigma fi di whole square. Since h is equals to 10, length of the class interval, n is equals to 50, next sigma fi di square, so which is equals to 105, and sigma fi di, which is equals to minus 15. Now substitute all these values here. H square 10 square, n square 50 square into 50 into what is sigma fi di square? 105 minus 15 whole square, that is 225. Clearly, which is 10 square 100, 50 square 2500, and 50 into 105 5250 minus 225. So we can calculate this. We will get 201. So this is what? Variance. Next, standard deviation. We know the standard deviation is square root of the variance. So square root of 201, which is approximately 14.18. So this is the variance and standard deviation. ఈ వీడియో మీకు నచ్చినట్లయితే లైక్ అండ్ షేర్ చేయండి, సబ్స్క్రైబ్ కూడా చేయండి. అలాగే ఈ వీడియోలో ఏమైనా డౌట్స్ ఉంటే కామెంట్ చేయండి. థ్యాంక్ యూ.